everybody, welcome to another episode of Daily IoT. On last episode, I showed you the code running on our PyCom for our Turkey Temp Tracker project, as well as how to get the Losant backend set up with the QOTD broker so that we could get readings from our device up to the Losant backend. And I just now realized, I believe I just called this the PyCom again, which I gotta stop doing. This is the YPy made by PyCom. I apologize, I keep messing that up. So the I almost did it again. The YPy. The YPy came in these really slick cases. It's this nice clear plastic case that has like a little magnet, a magnetic closing mechanism. This thing is really nice. Nicest case I've ever gotten an IoT platform in. Particle photon's right up in there too, but I like the magnetic action a lot better on this. Very nice. Anyway, I decided to take the case, cut a couple of holes in it, drill some holes in the front for the thermistor probes connections there, the female audio, I think they're audio connectors, but anyway, that the probes plug into, and turned out to be a really nice case. If you can see that, got the things in the front, power coming out of the back. And so we put everything into a case, really nice, so that we're ready to go for Thanksgiving Day. Now, I wanted to bring you up to speed on what I've been working on the last 24 hours, which is a dry run of this entire system. So today, I set all this up on my counter in my kitchen. I have one of those ovens that has like a top oven and a bottom oven, so you can cook two different things at different temperatures. Stuck the thermistors, the probes in top and bottom, set them to different temperatures, and turned it on and watched it in Losant. I built a little dashboard, which I'm going to show you how we built that here in just a minute, and just to see how everything worked. And as is almost always the case in any project you ever do, at least I ever do, things did not go well the first run through. And I ran into a couple of problems. The first was a divide by zero problem in my code where if you hit the rails of the analog to digital converter, and it pegs out one or the other, some of the math for figuring out the resistance of the thermistor resulted in a divide by zero. Thank you, Adafruit. This is why you don't just copy code from the internet without looking at it first. And so I took that, I modified it so we will not run into that, but it also exposed another interesting problem, which is I was using a 1 mega ohm series resistor with my thermistor because its nominal resistance is around a mega ohm. So you create a voltage divider. The problem that I found out is that as soon as the thermistors, I don't have them here, as soon as they heat up, that resistance, remember it's this non-linear curve, that resistance drops off very, very fast. So even like right around 100, 150 degrees, I go from a mega ohm of resistance on the thermistor down into the hundreds of kilo ohms. That's less than 100 kilo ohms. And so that really messes with the voltage divider. You want to pick a resistor that gives you really good swing, I'm going to call it, in the temperature range that you want to measure. I just said a lot of words. The short version of that is a 1 mega ohm series resistor with my thermistor was way too high to give me accurate readings in the temperature zone that I'm going to be monitoring, which is the oven and the turkey. And so easy fix, we just took we replaced the mega ohm resistors that I had in series with my thermistors and replaced them with some 10K resistors. And I get a much better voltage range output on the voltage divider in the actual oven temperature range than I was before. So that was the first problem. Second problem, divide by zero, the resistor. And then the third problem is my beta coefficient. I solved the beta coefficient for my thermistor using my fridge and freezer with the thermistors, and that gave me one number. I tried it again in the oven and I was getting a completely different number. And so the main takeaway from this is if you don't have the data sheet for your thermistor, as is the case in our project, I just picked these up off of Amazon. They're replacement parts for some other barbecue temperature sensing thing. Because I don't have those values, the Steinhardt coefficients or the beta coefficient, I'm just not going to get as accurate a reading as I would have hoped for. And so in my testing today, I'm probably off by anywhere from 30 to 40 degrees Fahrenheit. The hard part of this too is I don't know how accurate my oven is. And so there's a lot of things, unless you have a controlled temperature environment where you can say with exactness, this is the temperature and this is the resistance I get from my thermistor. It's a lot of guesswork. And so we're gonna be a little off, but that's not deterring me at all. I'm still sticking this thing in my oven and turkey on Thanksgiving Day, and we'll report back to you. But otherwise, the test went fairly well. We had pretty good results, seeing it in Losant, tracking the temperatures, and I built a couple of things in there, which again, I will show you in a minute. But that is the update. That's where we're at. A lot of learnings in this project. This is why I love doing this kind of things. You have an idea, you start implementing it, and then you learn all those fine details in there. And so that's where we're at. For the rest of the episode, again, like I said, I'm going to show you how to create a nice little dashboard in Losant that I can keep an eye on while my turkey is cooking on Thanksgiving Day. And so let's hop right into that. So this is the kind of dashboard that I'm going to show you how to make. We have our turkey temperature over here with some indication of what's happening, whether it's cooking or it's too hot or overcooked. And then the oven temperature over here, we can do things like see when it's preheating or if it gets too hot. And then down below, we just have over time a view of the temperature of the turkey as well as the oven. These are graphs of me playing over the last day, just going through a couple of cycles of oven heat up and cool down. And so let's show you how we go about making this. The first thing that we're going to do is come up to dashboards and click create new dashboard. We'll give our dashboard a name. We'll call it the real Thanksgiving dashboard, if I can spell. No description, as usual, create dashboard. And then you're dropped into a screen that looks like this, where you have no blocks currently, so it says which block do you want to start with. And so let's go ahead and start with our time series graph. We'll click on the customize button here. And what I really like about creating dashboards in Losant is that you have this preview over on the right-hand side, where you can see how your block in your dashboard is going to turn out. And so we'll give this a header text. We'll call this temp over time. And the application that we're going to pull data from is our Turkey Temp Tracker that we set up in the last episode. And now we have a couple of options here. We can choose a live stream where we get data as it comes in real time, or historical. And the reason I'm going to leave this as historical is because in the live stream, you notice that it says historical data is not available. So if we're not always looking at the dashboard, we don't get to see that previous information that was sent in through the data. And so we're going to leave it as historical. That way, whenever we open it, we can see data that goes back. And then it says the block will update at the normal dashboard refresh rate, which is fine. We'll use 60 minutes into the past with a 1 minute interval. Sounds great. And now we can set up the series for our graph. And so as you can see here, we have series 1. For the device ID, we're going to use our temp tracker that we set up. Again, that was last episode. And we'll go ahead and track food. And this label we will call turkey temperature. And the color we'll change the color here to something else, like maybe the color of a turkey there, something like that. In the y-axis label, we will say, actually, you know what? I have a degree Fahrenheit that I have off screen that I can copy with the actual symbol. So let's paste that in, degrees Fahrenheit. And we'll say that this is turkey so that it's clear. And you can see that that shows up over here. We're going to use both sides of the graph, as you'll see. So that's turkey degrees Fahrenheit on that side. And the min on that we'll say is 50 degrees Fahrenheit all the way up to 500. And then we're going to click add segment so we can add our oven in as well. Same thing from our temp tracker. The attribute this time will be oven. And the series label will be oven temperature. And that's fine, that color's fine. The y-axis label will again be degrees Fahrenheit, but this time we'll call it oven degrees Fahrenheit. And I'm going to use the same axis. You can change this to be whatever you want. You can have a completely different min and max than the turkey temperature. The reason I like to keep them the same is so that I can just look at the lines side by side. So now you see over on the right, I have my oven scale, and on the left I have my turkey scale, and as I get data points in, they will draw them both on this graph. So that looks excellent. We'll go ahead and click Add Block, and it shows up on our dashboard. Perfect. All right, now the point of a dashboard is to give us as much information as possible in a very visual way that we don't have to spend a lot of time digesting it. And so while it's nice to look at the graph over time, it would be better if we can have some immediate indication of what our main dish is doing as well as the oven. And for that, we're gonna add a couple of more blocks. We're gonna come over here and click on the little gear and do Add Block. And you can do a gauge, which will show us just the temperature. However, if we want to get a little fancy with it, we can scroll down a little bit more and create an indicator, which is kind of like a gauge with some extra sauce on top. So we're going to click Customize here on the indicator. And we're going to call this our oven temperature. And you can see, again, we have the preview. We're going to, again, use the Turkey Temp Tracker application. That's where we're pulling data from. And for this indicator, we're going to use the last received data point. You can see you have a bunch of aggregation options here, but we're just going to take the last data point received every time we get it. And now we need to add a query. What is the data that we want to populate this indicator with? And so we can just come to here and select our temp tracker from the device list. And the attribute is going to be oven from that data. And then you can see that it creates a value variable here called value-0 and a time variable time-0. And where those come in handy is down here in the conditions. What the conditions section allows us to do is add some logic around the value to change the look of the indicator. So let me show you what I mean by that. So we're going to click Add Condition, and we give it an expression. You see they give you an example here of how we can use that value that we just created up in the query. So we're going to do value 0. And let's just say for our oven temperature, if that is greater than, we'll say 410 degrees Fahrenheit, then we want to change the label. And to do that, we'll say something like too hot. And then come down here, and then we'll display the value like this. Value 0. And then we'll throw on our degrees Fahrenheit. And so that is what we'll display when the data that comes in shows that the oven temperature is over 410 degrees. That means our oven's getting too hot. Okay, so let's add another condition to do the lower side of that. This is what I would call the preheat side. Let's change the color on too hot to be red. That's danger or warning. We want to know about that. Call it out on our dashboard. Okay, so on this one, we're going to say same thing, value 0, using the variable like this with the double brackets. And we'll say if it's less than 350 or so, remember my thermistors are a little off, so I have to give myself a little bit of leeway here. If you had your thermistor very dialed in to give you an exact temperature, you could put those in here. You want to know exactly when it's preheated to 375 or 350 or whatever the temperature is that you want to cook your meal at. And so as long as the value is less than that, we'll say we'll kind of give it a cool color here, and we'll say that it's in the preheating stage. So we'll say preheating, and again, we'll just display what the value is so we can see it, degrees Fahrenheit. And then if it's in between those, so if it's greater than or equal to 350 degrees, but less than or equal to 410, that's right in our cooking zone. And so that will be our default. And in that case, we will simply display what the temperature is by saying value 0 degrees Fahrenheit. And so you can see that the last received value was 8.5 degrees Fahrenheit. Again, this is because of that nonlinear curve and how I have it tuned in to be most accurate in the cooking temperature, in that cooking temperature zone. And so when it gets below that, like at room temperature, the readings are wildly off. And so that's completely expected. And so that's it. You can see with an indicator, we can take one of our data points, look at it, put a query around it, and then put some logic to change the indicator and how it appears on our dashboard. So we'll go ahead and click Add Block. And you can see here, once we're on our dashboard, we can move these things around and resize them. It's all very configurable. Okay, so you get the general idea of how we just created an indicator. I'm not gonna make you watch me create the other Turkey indicator. It's the exact same process. You can come in here and you can do edit settings, and you can see, we can review these. Again, all we're going to do is create a query with the temp tracker. We'd select the attribute to be food instead of oven, and then we do very similar things to create the conditions for our turkey, whatever the done temperature is. And so let me just show you that in the existing one so you don't have to watch me go through that again. So if we come in here to the turkey temperature, we do edit settings. Again, we're using last received data point. And again, we're choosing food as our attribute. And right here I have, if the value is over 180 degrees, we're going to say you've overcooked it. Let's put an exclamation point there. It'll turn red. If it's less than 160 degrees Fahrenheit, then we're in the cooking phase. And if we're in there between those two numbers, we're going to call that ready to eat. And it'll turn green. And that's a nice quick visual indicator that everything is good. We'd see green on the meat, meaning it's done, the oven temperature is good, and we'd see the graph over time. And so that is just very quickly how we can create a dashboard to give us meaningful, actionable, an actionable view of our temperature data coming from our thermistors. I wanted to add a little bit more on top of this, and this is what's really cool with Losant. It's really easy to get a little bit out of control because there's so many things that you can do, and lots of ideas. Once you know what all the pieces are, it's really fun to expand this and make more things happen. And so let me show you some extra goodness that I added here. If we come into our application here, the Turkey Temp Tracker, and let's take a look at our workflows. I created this preheat notify workflow. And let me walk you through this really quickly. What I wanted to know is, once the oven is preheated in that temperature range that I consider preheated, I just wanted to get a text. Maybe I'm down watching a football game or something and I'm not near the oven, or I'm outside and I want to know that the oven is ready to go. So let's take a look at how this works. We have our trigger here at the top, which is a new reading has come in to our temp tracker device that we set up within Losant. So we just got a new reading from our thermistors. What we're going to do is we're going to come down here and we're going to grab a local storage variable. So I only want this workflow to execute a single time. Well, the trigger is going to trigger every single time a reading comes in, but I only want to send myself a text once when the criteria is met for a preheated oven. And so to do that, I need to keep track of whether I have sent myself a text or not. And the way we accomplish that is, if we come over here to the side, there's this little storage tab that says manage the persisted values for this workflow. And so what we can do here is create a local storage value that persists across runs of this workflow. And so I just created a new one. You just do it right here. You give it a key, select a data type and a value, and you set value. And you can see my notified is set to 1 because I already ran this earlier. But we can just as easily clear that out. Nothing's stored there. And I'll show you, we just do notified, just to show you how we would go about this. Set it as a number, and I'm going to set the value to 0. I hit set value, and now you can see it shows up down here. I have notified, the value is 0, and it's of type number. And so all that block right here does is get that variable. I want to grab the notified key out of my workflow storage and store it in the payload path of data.notified. Then we're going to come down to this next block here, and this is our conditional block. Have I been notified yet? And the expression here is very simple. I want to know if the temperature of the oven is greater than 375 degrees. Remember, my thermistors run a little hot, so it'll read higher than that when it gets to 375. And data.notified does not equal 1. So I have not notified myself that the oven is preheated. And if that's the expression. And then I've got two paths here. I've got the red path, which is false, and the green path, which is true. If I get rid of this block here, you'll see that it's green. So this is the true path over here. So if those conditions exist, that the oven is greater than 375 degrees and I have not been notified, then text me. And this is just a text node from down here in the node palette. You just grab the SMS node here and drag it in, and you put your phone number in and a little message template. The oven is preheated from the Losant Turkey Temp Tracker. And then after I send myself a text, we are going to come back to a data value here of storage set value. And we're going to take that key from before, that notified key from our workflow storage, and we're going to store it, and we're going to change the value to 1. That way, the next time we come through here, it will not send me another text. So I won't get a text every single time that the oven is over 375 degrees. That would be super annoying. So this is just an example of a very simple workflow that you can add to enhance the application. And so if we wanted to do something similar, like send me a text when my turkey is finished, watch how easily we can do that. We've got the workflow here. We can come over and we have this option to export. I have to deploy it first since I made changes. So I'm gonna go ahead and deploy it. It's ready to go. And then I have this export option. I'm gonna click on that, and you can see that you can export it to a file. This will save all of the settings out, so you can give this to somebody else and have them import it into their Losant workflow, or they have this nice option right here, copy to new workflow. And we'll call this, instead of preheat notified, we will call it the turkey done notify workflow. We click export workflow, and right now you can see that we've changed over to the turkey done notify. And now we have the exact same workflow. We'd want to do something very similar. We'd want to get a new reading from the temp tracker. When it comes in, we want to get the variable. Now you'll notice that if I come over here to storage, I do not have that notified variable. So we just need to create that notified as a number, and we'll set the value to 0. And now we're good to go. You can see that there. Notified yet, we're going to change slightly. We don't want to look at the oven variable anymore. We want to look at the food variable. So we'll say when the data.food is greater than, what's the done temperature for chicken? Like 180 degrees, I think, 180 degrees Fahrenheit. And again, data.notified is not equal to 1. Then text me. And instead of the oven is preheated, we will change this to your turkey is ready. Just like that. And same thing at the end, we're going to set notified to 1 so that this only triggers a single time. Once we do that, we can click deploy workflow, and just like that, we've duplicated. We've got now a notification when our oven has been preheated, as well as a notification when the turkey is done. And so very, very quick to set up and very easy to see visually in the Losant workflow editor. Okay, and that's it. So I hope you can see this theme with Losant, how once you know what all of the different pieces are and what's at your disposal, it's very easy to put things together. Once you have your hardware working down in the real world, putting together things and making magic happen in Losant is almost trivial in my opinion. It's very, very easy. And so I really like how that came together. Hopefully you found that useful. If you have any questions on any of this, the Losant part, the hardware with the YPi, I almost said PyCom again, please let me know. Stick them in the comments, hit me up on Twitter, Instagram, reach out via email, kevin@sidwar.com. I'm always happy to try and answer questions. Question of the day. Ooh, I'm gonna have to think about this one for a second. We talked about cases. This is, I'm gonna label it top case I've ever gotten an IoT platform in. What is the best unpackaging experience you've ever had for a product? That thing that came and just the box was amazing, and opening it up was almost as good, if not better, than the actual thing inside. Let me know down in the comments. I appreciate everybody watching Daily IoT, the show where together we're learning how to make the Internet of Things one day at a time.